run this, minimize it, and then take a screenshot. If I look at the definition of slope, it's rise over run, correct?
Okay.
And what that is the difference in the y coordinates divided by the difference in the x coordinates.
Ah.
Well, here they give us a set of x and y coordinates.
They do.
Okay. So, and even though they give the answer as a minus r times b minus s, believe it or not, this equation that I just wrote is the same as doing it this way. Y sub 1 minus y sub 2, as long as I do the bottom in the same order. Okay, so both of those give you the same answer. Now, what they've given us is this method, and instead of giving us rise over run, they've given us the run times the rise. That's basically the run. And that's the rise.
How do you know that's the run?
Well, the run is the difference in the x coordinates. Those are the x coordinates.
Oh, okay.
The rise is the difference in the y coordinates.
Okay.
Okay. Now, this is a great problem because they don't give you the obvious. They could have just said a minus r divided by b minus s has to be less than 0. And that is truly for sure. If this is a negative slope, then that has to be less than 0.
Okay.
But the only way that can be less than 0 is if either the numerator is positive and the denominator is negative, or vice versa. All right? In other words, this quantity there, for it to be less than 0, the numerator and the denominator have to have opposite signs. When you divide a positive by
so one has to be plus and one has to be negative.
I'm sorry, I didn't quite hear what you just said.
So one, the top should be positive and the bottom negative, or vice versa?
And if I apply that same reasoning to that expression right there, one has to be positive, one has to be negative, therefore they're both less than 0. That proves negative slope. In other words,
so A and B are X.
X and Y.
R and S are Y.
No. This is X, that's Y. That's X, that's Y.
Oh, I see, okay.
That's maybe x1 and y sub 1. That's x2 and y sub 2.
So the y's are all negative.
No, we don't know if the y's are negative or positive. But what we know is that, see where I'm check marking? Excuse me. This right here. Here. This right here.
Yeah.
That we're trying to prove is negative.
That y1 is negative?
Nope. That the whole thing is negative. That y1 minus y2 divided by x1 minus x2 is a negative.
Oh, I see. It's less than 0, so it has to be negative. Got it. Okay.
And the only way that is true is if either that is positive and that is negative, or vice versa. But the numerator has to be opposite sign of the denominator. It's the only way you can divide a by b and get a negative number is if a and b have different signs.
Okay, so
Well,
we?
one of these, that is x1 minus x2, and this is y1 minus y2. So if they have to be opposite signs up here, then they have to be opposite signs down here. And it's either I got a positive times a negative, or I got a negative times a positive. In either case, it's less than 0. So this does indeed mathematically prove that that line has a negative slope. Because you do understand the way I was proving it before was not mathematical proof. It was
Right.
just I tried 3 or 4 different lines that I could think of, and I wasn't able to disprove it.
Right.
I said, okay, that constitutes good enough. This is mathematical proof.
Okay, but when you say minus and plus above, or plus and minus, I mean that the signs are different, that's still just plugging in numbers, right?
No, no. Very important. This is what slope is. Rise over run. That translates to this. Y sub 1 minus y sub 2, y differences, divided by the x differences. Now, for a slope to be negative, the y differences have to be the opposite sign of the x differences. And I don't care which one's positive and which one's negative. I know they have to be opposite signs, because when you divide a positive by a negative, you get a negative. When you divide a negative by a negative, you get a positive. So the only way we get less than 0 is if they're opposite signs.
Okay, but as of right now, the way it's written, we don't know if they are opposite signs or not.
Yes, we do. Well, yes, we do. Right here. That says the same thing as that. It's just not quite in the same format. In other words, this is dividing one thing by another is less than 0, meaning they have to be opposite signs. This is multiplying one thing by another and saying it's less than 0. Well, this means the same thing. It means one of them has to be positive and one of them has to be negative, or the other way around. It means the same thing. What they're telling us in C is this. That also has to be true.
So in other words, if I'm understanding you correctly, they're essentially writing the same equation just in a different way.
Not quite. No, that's why it escaped me the first time when I was looking at it, is that I was looking for rise over run. And they didn't give us rise over run, they gave us rise times run. In other words, they told us that the rise times the run is less than 0. But that is conceptually the same as saying the rise divided by the run is less than 0. You can't have one without having the other. So this statement alone proves that the rise divided by the run is a negative number. That makes the slope negative.
So I'm sorry, conceptually, I'm still having a hard time with this.
Well, perhaps
I understand what you said about the equation.
It might not be worth spending the time on. I'm not sure that the way I didn't do it the first time isn't the way you'd want to do it. The fastest way is you just sit there and try to draw some slopes, positive slopes, and put your A, B, R, and S on there and see if you can get it a positive slope that has a negative answer, and you can't do it. I tried 3 or 4 different ways. So that's probably the best way to do it. I'm not necessarily saying that this algebraic way is the best way for you to do it. Here's the thing.
Okay.
Here's the thing. I've read done a lot of research on this, and what I've read is the major difference between instructions in math in Asia and the United States is that the United States will give a student 20 problems to do in 1 hour. In Asia, they'll give that same student 5 problems, but 4 different ways to do each problem. And the Asian method of teaching mathematics is far more effective than the US method. So I am a huge believer in this concept of taking a problem and attacking it from 4 different angles. There's always multiple ways to solve these math problems. And usually we only do one way. And that's fine, but when I do discover a second way, I usually will mention it. And that's all I'm doing today.
Okay.
Mentioning that there was an algebraic way to approach this. We didn't have to do it visually.
Okay.
Okay? And I don't think it makes much sense to spend more time on it. Whether you get this second way or not, it's probably not worth pursuing that. Although this concept of slope is very important. You definitely need to understand slope. And you need to understand it in the concept of being rise divided by run and what that means about the 2 points that you're giving. In other words, if they give you 2 points, you need to be able to figure out the slope between those 2 points.
Okay.
Okay? Did that one. Did this one. I think 13 was the last one we worked on. Yeah. All right. 14. Hold on. I got to take a screenshot. Problems like 14, I automatically always draw a chart.
Okay.
Just to get a feel for the problem. Okay. I don't mark off the grid because that takes too much time.
Sure.
But I can approximate where that point is. Minus 6, minus 7. We'll call it right there.
Okay.
Problem is here. Hold on. Let me start this again. Give myself a little bit more room because they're in negative territory. So minus 6, minus 7. There's the center of one circle.
Okay.
And minus 6, 5 lies inside the circle.
Okay.
8 minus 7 lies outside the circle. So therefore, I must have a circle something like this. You with me?
Correct.
Okay.
Yes.
So there's my picture. Now, that tells me that the radius has to be greater than a what?
Greater than
vertical.
The difference between
Correct.
5 and negative 7,
Which
right?
is 12, yes. And it tells us that the radius is an integer. Well, hold on. Let's get to that. At the moment, the only thing I know is the radius has to be greater than 12. Not greater than or equal, but greater than 12. Otherwise, this point would not lie inside the circle. If the radius was exactly 12, it would lie on the edge of the circle.
Right.
Okay. This tells me what about the radius?
That it's...
Excuse me, I think, no, I did that right. Oh, go ahead. Sorry.
I'm not sure.
Well, what's the distance between the x coordinates of those 2 points?
The x coordinates.
Distance between -6 and 8 is what?
-6 and 8
There's the
would
export.
be
Go ahead.
-2.
No, we're not cared about the sign.
2
Nope.
or 14?
14. That tells us the radius has to be less than 14.
Oh, I see what you're saying. Got it.
Because this point is outside the circle, therefore it has to be further away from the center than the radius of the circle is. And it's
Right.
14 points away. It doesn't matter if you do -6 minus 8 or 8 minus a -6. What's key here is knowing the distance between these 2 points, the absolute value of it.
Okay.
Okay? So we know the radius got to be greater than 12 for this first point to be inside the circle. It's got to be less than 14 for this second point to be outside the circle. And if we read all of the information we have here, if m is the radius and m is an integer, then it's got to be, well, what integer is greater than 12 and less than 14?
13.
The only one. As I said, it can't be 12 or 14. Otherwise, those 2 points would have been on the circle, not either inside or outside.
Aha. Ah, hold on a minute. Hi, Brenda. Good. Sorry about that. That was my broker calling me, and I can't talk with her right now, obviously, so I passed her off to my husband.
Okay. All right, number 15. Well, that's an interesting broker that's calling you on a Sunday.
Yeah.
That's a passionate stockbroker, for sure. I used to be a stockbroker, and boy, I don't remember ever calling anybody on Sundays. But okay, so
Well, she needed to get a hold of my husband before he leaves on his trip tomorrow.
oh, okay, I get you. Okay, 15. 15 is going to be one of those problems where when it says which of the following must be true, we're just going to go through every one of them and see if we can disprove them. That's always the secret when they want you to prove something is true, is see how hard it is to disprove.
So just for my clarification, that's a negative m over 19?
It is.
Okay, it's kind of hard to see.
Yes, I had the same question. They don't put the fraction bar, or they put the negative sign on the same eye level as the fraction.
Right. Plus my computer screen is just a little dirty, so.
Okay. M is an even integer. So what even integer can I come up with to disprove that?
Oh, okay.
Hold on, let me think for a second. Excuse me. Well, yes, no, we know that that's even. Okay? So can you think of a positive m that would make that not even?
So.
In other words, they say, does that mean that m is a...
Oh, the whole thing is an even integer. Okay.
Yes. The question is does that prove that m is a negative number? Well, if I can come up with a non-negative number for m, then I've disproved it. How about 38? We're going to let m equal 38. What do I get?
Does that mean 19 is negative?
No, what it means is that minus m divided by 19 is minus 2, which is an even integer.
Oh, I see. Okay, so it doesn't matter if it's negative or not. Okay.
It doesn't. That's the trick. So that's not true, because I just found an m that was a positive number, and it still makes the ratio even, integer.
So now we try a negative number?
No, we're done with A. We disproved it already.
Right, but if you move on to B.
Yeah. So that's false. And now B, m has to be a positive number. Well, I could let m be negative 38. And now negative 38 divided by 19 with a negative sign in front of it, that's positive 2.
So that doesn't work either.
The m doesn't have to be, in other words, I just proved that m can be positive or negative.
Mm-hmm.
Now, does m have to be prime?
So 17.
Well, yeah, here's the problem with prime, is prime numbers aren't divisible by anything. So if m is a prime number, there is no way that m divided by 19 is going to be an even number.
So that's false.
That's impossible. Yeah, in other words, m can't be prime, in fact. Not only is that, in other words, it doesn't prove it. In other words, in these two cases, m could be negative, m could be positive. So you can't state either one of these. But with C, I could definitely say that m is not prime. The only prime number n could possibly be would be 19. And that gives you minus 1, which is not an even integer. And any multiple of that, well, that's clearly not a prime number. Nor is 57, nor is the next one up. And so all multiples of 19, none of them are going to be prime numbers.
Correct.
So m is an odd integer. Well, just showed that m could be 38. And 38 divided by 19 is an even integer, and yet m was not odd. Now, in other words, you see how I disproved D? Is I found an even integer that made this statement true.
Right.
If that statement is true when m is an even integer, then it clearly doesn't mean m is an odd integer.
Okay.
Now, practically speaking, you're done at this point.
Right.
You answer E and you go on to the next. And that's exactly what I would recommend if you're taking the test. But for the sake of understanding this problem a little bit more, let's just examine the last one and why that is true. M has to be an even integer. Well, the first one we tried was 38, right?
Yes.
And that gave us an even integer. But if I go up to 57 and divide it by 19, I get an odd integer. To get an even integer, I got to go all the way up to 76, add another 19, and I get an even integer. Notice that all my even integers have an even m.
Yes.
When I use odd m's, even when they're multiples of 19, I get odd integers.
Right.
So this does have to be true. M has to be an even integer.
Okay.
All right. Ooh, this is a good one here. Good in the sense that some of these problems I would have no idea how to solve mathematically. But luckily, you can solve them by trying numbers. And as you've seen, that is a very common method of approaching some of these problems. In fact, I want to say a third to a half of the problems, you're going to try numbers.
Okay.
Okay.
Do you have a strategy as to which numbers to choose?
Well, in this case, yes, I do, actually. Choose the smallest ones you can think of that aren't 1 or 0, because that rarely proves anything. Because 1 divided by 1 is the same as 1 divided by 1. So 1 isn't necessarily a good number, and 1 times 1 is also 1. So 1 isn't the best number to choose. But in this particular case, they tell us that v is the square of an integer, and v is greater than 1. Well, here's your list of perfect square numbers. So they're saying v is one of these numbers, up to infinity. You see why these are the perfect square numbers? That's 2
Yes.
squared, 3 squared, 4 squared, and so forth. So v is a number like this. In other words, v is not 5, v is not 7.
No.
V is one of these numbers or higher.
Mm-hmm.
Okay. Well, they're saying that which of the following numbers has to also be the square of an integer? Like that. Well, 81 is a perfect square number. In fact, it's the next one on the list.
It is.
If you take a perfect square number and you multiply it by what they're telling us is another perfect square number, guess what? You get perfect square numbers. Something I really didn't know until today.
Oh, really?
If I multiply 4 times 9, I get 36. That's a perfect square number.
Oh, yeah.
If I multiply 4 times 16, I get 64. That's a perfect square number. If I multiply 4 times 25, I get 100. If I multiply 9 times 16, I get 144. That's perfect square of 12.
I didn't know that.
I didn't either. But now what we know we're looking at here is we have one perfect square number times another perfect square number. The result has to be a perfect square number. So A is true.
Okay.
Okay. And that was a little bit of a combination of picking numbers. I didn't mathematically prove it, but awfully good argument for it. And that's really all you're looking to do. You're not necessarily looking to prove it. Now B, notice that none of these would be easy to solve algebraically.
Right.
Okay, I mean, these things are ridiculous. Almost the only way to really look at these is to try some numbers. So B doesn't look like it would be correct, right? I mean, there's nothing magical looking about B that would indicate to me that that's a perfect square number, but let's try some numbers. Let's try small numbers. Let's try 4 for V. Well, if I try 4 for V, I get this. That is 121.
Which is 11.
Perfect square number.
Mm-hmm.
That's 11 squared.
Yep.
So all I need to do is really try one more before I'm convinced. I'm going to try 9. And again, we know that time is an element here, so you can't waste time, more time than is needed on these things. So if it works for 9, I'm going to assume that B is also correct. Well, 9 times 25 is 225. Plus 10 times 3 is 30. Plus 1, that is 256. Gee, excuse me. 256, that's a perfect square number.
Which square is that?
16 squared.
Oh, okay.
So oddly enough, even though that thing looks really strange and I have no idea why that ends up having to be a perfect square number, it is for 4 and it is for 9. Now, if I wanted my degree of certainty to be higher, like 99%, I'd maybe try a couple more numbers. But I'm not looking for 99% certainty. Because
Right.
99% certainty means I got to spend 5 minutes on this problem, and I only have an average of 2.5 minutes to spend on it.
Right.
Okay, so let's do the same thing for C. In other words, some of these may be easy to disprove if the very first number we try doesn't result in a perfect square number. Well, always use your low numbers, the ones that make the math easiest. So this one is 4 times 4 squared plus 4 times the square root of 4 plus 1. Well, 4 times 16 is 64. Plus 4 times 2 is 8, plus 1, 73. That is not a perfect square number. So all I had to do was try one number to prove that that is not a perfect square number.
Right.
Okay. All of these problems seem like they take a lot longer than they should, given that you only have 2.5 minutes average. But part of that is I'm explaining different approaches and stuff.
Sure.
Okay, so what we have here is a chart for the reaction time it takes you to hit the brake when needed. In other words, you're going 50 miles an hour. Whoops. You're going 50 miles an hour and an animal runs out in front of your car. How long does it take you to hit the brake? This tells you you're going to move 55 feet before you hit the brake. Your car will. That's a measure of reaction time. That's the amount of distance your car moves between the time you see that you have to hit the brake and when you actually touch it.
Right.
On the right, we have the distance traveled after the brakes have been hit. So if you're going that same 50 miles an hour, your car is going to move another 140 feet, 137 feet, I guess, after the brake. The total distance your car is going to travel is the sum of these two. So you could say that if you're going 50 miles an hour, the car is going to move 55 feet before you hit the brake. It's going to move another 140 feet after you hit the brake. It's going to go 195 feet before you stop.
Okay.
Okay, so that's how we understand these two. Now, let me think how I was going to do this here. I want to open both of these at one time. Let's see if it lets me open it a second time. I don't know that it will. No, it does not. All right. Well, part of the problem with here, let me minimize everything so that we can at least read one problem at a time while still looking at the curve.
Okay.
Can you read 17? And they tell you everything I just told you. Total stopping distance is the sum of the distance of the first chart plus the second chart.
Okay. The speed in miles per hour at which the car travels a distance of, I think that's 52 feet during reaction time is closest to which of the following?
Okay, now let me blow this up. 52 feet is the distance that we're going to travel. So what speed, looking at this chart here, what speed would go with 52 feet in distance?
So
there I go to 52 on the vertical scale.
So around 45?
Okay. Now if we look at our answers, You got to be a little more precise because they gave us a 43 and a 47.
Well, do we also have to look at the other chart too?
Nope. This is strictly reaction time.
Oh, okay, during reaction time.
Mm-hmm. So here,
Okay, can I see the chart again?
Okay, so here is 52. Right
It says reaction
there.
time is the time period that begins when the driver is signaled to stop and ends when the driver applies the brakes. So don't we need to do both charts?
No. Reaction
because it's
time
just
is when
asking
you
for the
touch
speed.
the brakes. That's the time that the car travels between when you realize you need to touch the brakes and you actually touch them. Once you've hit the brakes, this chart takes over. But this chart on the left is strictly the amount of time it takes to hit the brakes.
But it says during reaction time.
Which is the title of this chart on the left. Reaction time is the time period that begins when the driver is signaled to stop and ends when the driver applies the brakes. This chart over here on the right starts when the driver applies the brakes.
Okay.
Okay? So what we're looking for on the chart on the left only for number 17 is where the distance is exactly 52. That's about as close as I can come to it. That's
Okay,
halfway
I
between.
can't see the chart.
You can't see the chart on my page?
It's very small.
Okay, let me blow it up here. Because for this particular problem, we need resolution because they gave us a couple of different answers that are close.
So 52 is the distance?
Right. That's the distance that is traveled, and they want to know what speed you were going. So what speed? There's 50.
Oh, so we need to go. Okay, now I see where you are.
There's 50.
So that
right?
looks more like 47.
Exactly. In other words, if I go down to the speed, it's closer to 47 than it is 43.
Right.
And since those were our two closest choices, 43 and 47, clearly it's got to be 47.
Right.
Okay. Now, again, this is going to be tough because it's hard for me to show you the questions and the graph at the same time.
Well, I can look at the book.
Okay. Approximately what is the total stopping distance in feet if the car is traveling at 40 miles an hour? Well, that's pretty easy. Let's go. You don't need to look at the book on this one. We can go up and look at the graphs. So it's saying the total when you're going 40 miles an hour. Well, this says the total is the sum of the two distances. Right here, that note. Total is the sum of both distances when you're going 40. So how long does it take? How far does the car go between the time you know you need to hit the brakes and hit the brakes? When you're going 40. A speed.
So it looks like 88.
Right there.
So
45.
45 plus 88.
Okay, now I hadn't gotten to this chart yet, but yeah, that's 88. So 88 plus 45 is 133. Let's see if there's got anything close to 133. 130.
Okay.
Okay. 19. Of the following, which is the greatest speed at which the car can travel and stop with a stopping distance of 200 feet? This is actually a pretty good question because this tells you how fast you can go and you'll still be able to stop short of 200 feet. So if a kid runs out on the road and you're going less than that speed, you'll be able to stop in time. If you're going greater than that speed, you won't be able to. So now, because there are two charts, it's going to be hard for us to calculate that. So here is a perfect back-solving problem.
Okay.
Now, in other words, what we're going to do is we're going to start with the answers and see if we were going 50, how far would we go? Well, we just figured out that we would go 133 feet, or 130 feet, I guess, going 40, right?
Right.
Okay. So clearly we got some additional speed we can go without taking more than 200 feet to stop.
Right.
So if we're going to back solve this, in other words, by taking the answers, plugging it into both charts and figuring out how far we go, where do we want to start? Which answer?
The middle?
It wants the greatest speed. If I tried the middle speed and it worked, that wouldn't tell me anything.
So you start with 70.
Yes. And if 70 doesn't work, you do 65 and then 60 and then 55 and 50. If the question said the least speed, then I would start with 50. Yeah, exactly. So, and if it doesn't say anything at all, starting in the middle isn't a bad way to go. So let's plug in some of these numbers into our charts. We're starting with 70 and working our way down and see what we get. So 70 gives us that. Whoops, hold on a second.
65 miles per hour.
Hold on. We're going to 70 miles per hour. That gives us 78 feet that we would move before we even hit the brake. Now over here, if we're going 70, we're going to go 269 feet. So clearly we cannot go 70.
Right.
Let's try, you know what? We're so far over 200 that I'm not going to try 65. I'm going to skip and try 60. Because my suspicions are that 60 is going to be over also. And then we won't have to waste the time doing 65. If 60 is under, then I'll have to do 65. Okay? Right. Well, what's 60 give us?
Because 60 looks like it's 190.
198 plus whatever that number is.
Am I right?
Yep. So 60 isn't even close either.
If we just look at the distance with the brakes.
Right. We're going to go well over 200 feet if we're going.
So that's too high, isn't it?
What's that? Carolyn, can you hear me? Your audio is breaking up a little bit.
I was 50 looks to be
well, here's the problem.
Can you hear me now?
Yes, I can. Okay. So let's say we jump all the way down to 50. I'm going to show you the fallacy of doing 50. Okay. 50. You go 55 feet before you hit the brakes. And over here, you go 137 feet. So you go a total of 192 feet. That works. Does that prove it's the maximum speed you can go?
No.
We didn't try 55. So that's why you don't want to jump to 50. Even though you think it's probably the answer, you don't prove that it's 50. But if I try 55 and it works, I'll know the answer. If it doesn't work, I'll also know the answer. Right?
Right.
In other words, if 55 doesn't work, I'll know the answer is 50. Well, here's 55, so you go 60 feet there. And over here, when you go 55, boy, you go 175 feet.
That's 135.
That's 235. So 55, excuse me, Yeah, 55 is too fast also. Therefore, again, we're done with the problem. We've tried every answer that wasn't the smallest one, and there's no need to try 50. Either 50 doesn't work and they gave us a typo, but we proved that one doesn't work. We proved 55 through 70 didn't work. We didn't test 65, but we didn't need to. 60 was too fast, and 55 was too fast. So here's a case where when I try 70, my distance was so far greater than 200 that I might even gone to 55 next. Because if 55 doesn't work, I have my answer with just two steps. Whereas if I do it the slow, monotonous way, I would have to try 65, I would have to try 60, and then I would have to try 55. Then I would know my answer was A. And each of these steps didn't take very long. The way they've got it set up, it's pretty easy to do. But nonetheless, it is kind of an example of you don't always have to back solve every single solution. Sometimes you can speed the process up a little bit.
Okay.
Depending on what you get when you back solve the first number you tried. Okay, the total, hold on a second, let me scroll down a little bit. The total stopping distance for the car traveling at 60 is approximately what percent greater than the total stopping distance for the car traveling at 50? All right, let's go up and figure out those two distances and just compare them. So 60, it turns out we needed to do after all.
Yeah.
No, I didn't skip 60. I skipped 65.
So that's 198, right? Plus.
No, 60 is, let's see, let's put a number of 66 on that.
Plus 65 or 66.
Plus 198. That number is 198. But only because they've labeled it. See the 198 right there?
Right.
Okay. So 66 and 198 is 264. That's how far you're going when you're going 60 miles per hour. And now 50 miles per hour.
So we got to keep track of our answers in these.
Right. So 50 is 55 here. And over here, it's 137. So when I add those two together, I go 192. Their question was, how much percentage difference do you go from going from 60 to 50? Well, the difference is 72. Now the question is, do I divide it by 264 or do I divide it by 192?
What do you mean divided by those numbers?
Well, when you're figuring out percentage change,
right?
Let's say a candy bar goes from 10 bucks to 12 bucks. What percentage change is that? You take the
10% is $1, so it'd be 20%, right?
Right, but what you do is you take the difference, the price change, and you divide it by the original, always the original. If the price goes from $10 to $7, you take the price change and you divide it by the original, so you've had a 30% drop. Okay? So when you're figuring out percentage price or percentage changes, it's not just the difference that matters, it's whether you're going from 60 to 50 or going from 50 to 60 makes a difference. Okay? And this one, I believe, said 60 to 50. No. What percent greater than going at 50? So the two numbers I'm comparing, what were they again? One was 2. Remember what they were?
Not off the top of my head, sorry.
The difference of 72, I remember that.
Can you do a back? Can you hit the back arrow?
Unfortunately, on this thing I can't.
Really?
Yeah, this is a weird program that I'm using here. I think I just haven't figured it out. Let's do 50 again. Hold on.
Because I see a back arrow up there.
Yeah, but that doesn't take me back to my writing. Yeah.
Huh.
Does
it on the...
I don't see what back arrow you're seeing. As long as we're talking about this, what back arrow are you seeing?
Okay, so see where the tab says GRE practice test?
Uh-huh.
Go one left and it says my WPS.
Well.
And then go 2 left of that and you see the back arrow.
Okay, but unfortunately that's going to give me a back arrow on this. It's not going to show me what my writing was. I clicked on that and nothing happened. Yeah, something happened, all right. Not what I wanted to happen. Hold on a second, let me reopen it. All right, we can figure this out real quick here. Hold on. This program I use to read these PDF files is a little flaky sometimes. All right, so let's just, these aren't hard to figure out. Let's just do it real quick again.
Okay.
So 50 miles an hour was 55 plus 137. That's 192. And the other one was 66
something.
plus 198. That's 264, excuse me. There was a difference of 72. Now, their question was worded a little funny. How much further is 60 miles an hour compared to 50? So their starting spot is the 50, the 192.
Okay.
They want to know how much bigger is 264 than 192. Well, it's 72 divided by 192, not divided by 264.
Oh.
That's the key. And that number is 72 divided by 192, 37.5%. 36 right there. Oops, hold on.
Okay.
Wrong question.
Up. 38%?
38%, yes. And usually they're pretty good about not putting anything else close to that.
Uh-huh.
And the reason is because it's hard to read a precise number off those graphs. So it's very difficult to come up with a precise number. And in fact, they had one on there where you remember the correct answer was 47 and you estimated 45, but they had a 43 and a 47 on there. So you have to be really as precise as you can be, but normally they won't make it a big problem. In other words, they don't really have anything close to 38% here. So it's not that hard to do that one. All right. Should we try one more?
Sure.
This is a good one. Another factorial one. From what I've gathered, we've come across 2 factorial questions, right? One was in the first part of the test one, and the other is in this part.
Mm-hmm.
So you're definitely going to be tested on factorial. Now, this is, I'm gonna write this 25 factorial like this. Dot, 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 2.
Okay.
If you like, dot 1, although the 1 isn't necessary.
Okay.
Okay. What is the least positive integer that is not a factor of this and is not a prime number? Well, none of these are prime numbers. They're all even numbers. Therefore, unless one of them is 2, it's not a prime number.
Wait a minute. The least positive that is not a factor of 25 and is not a prime number?
Right. So we can immediately see that all their answers are not prime numbers. We don't need to care about that. Okay. So now is all we're looking for are numbers that are not factors, and that is not 25. That is 25 factorial.
Right.
So the question is, can I divide 25 factorial by 26? Yes, because 26 is 13 times 2. And there is a 13 in the numerator and there is a 2 in the numerator.
Okay. You just cancel those out.
Exactly.
So, right.
If I said is 4 factorial divided by the number 3, does that result in an integer? Yes,
Yes.
it does. If I said 4 factorial, can I divide that by the number 8? Well, the number 8 is 4 times 2. So yes, I can.
Okay.
So that's my strategy here. This
Got
could
it.
be to take the number they're trying to divide by and making it numbers that are multiplied together that both reside in the numerator.
Right.
Okay, well, how about 28?
2 and 14 for 28, right?
Oh, that works. Let's keep going. And notice that I'm starting from the bottom and working my way up because it said what was the least. In other words, if I started with 58 and it works, I don't know that that's the least. Maybe 56 also would have worked. So it's important to go in the direction that it asks about. They want the least, so we got to start from the bottom up, because if we go from the top down, we don't learn anything. 58 might work, but it might not be the least. How about 36? So we know this doesn't work, that doesn't work. About 36?
Well, 36 has 3 and 18. It also has 2 and 12, and it also has 6.
Okay, 6 times 6 doesn't do it because there's only one 6 in the numerator. But it is 18 times 2, and there's an 18 in the numerator, and there is a 2 in the numerator. So 36 does produce, it's a factor. 36 is a factor of 25 factorial. About 56?
I'm not sure.
Well, 56 is 28 divided by, or times 2. There's no 28 in the numerator. But 28 is also 4 times 7. So it's 4 times 7 times 2. That's what 56 is. And there's a 2 in the numerator, there's a 4 in the numerator, and separately there's a 7. So yes, 56 is a factor also.
So
again, we're done with the problem, on to the next.
Right.
But for explanation purposes, let's try 58. Well, 58 is 29 times 2. 29 has no factors. If 29 has no factors, then I'm not going to find it in the numerator. I'll find the 2, but then I'll be left with a 29, and 29 is not a factor of what's left.
Correct.
It can't be, only because it's prime. If it's prime, not true, I guess. Not true. If I said 58 divided by 29, that does result. 29 is a factor of 58, but we don't see any 58s up here.
Right. So
it turns out that I don't actually have to prove that 58 doesn't work. I've exhausted my possibilities. I know that A, B, C, or D do not work.
But it says and is not a prime number. Is 29 a prime number?
No, 58's not a prime number.
Oh, okay, got it.
In other words, they're saying all of these answers.
But none of those numbers are prime.
And none of them were in the first place. They at least should have stuck a 27 in there.
Right.
That's not prime, but at least it's odd.
Right.
It's been a little bit more challenging. The fact that they gave us nothing but even numbers, I don't even know why they put that second part in there.
Right.
All right. That's probably a good place to stop. Number 21.
Okay.
Now, there's only 4 more on this, so before our next session, if you can, send me another practice test.
Sure, I can do that.
Or you can do it at the same time. In other words,
I'll probably do it beforehand because it's easier for me to just take the pictures ahead of time, make sure they're readable, and send them over.
There's only one difference. When you send it to me beforehand, it gives me a chance to look at them, give some thought to them, which I can't do in real time. And so,
right. So I'll send them ahead of time.
No, I'm saying sometimes there's an advantage in you seeing how I attack a problem when I haven't had a chance to look at it ahead of time.
Okay.
Because that's what you're going to be doing on the test.
Okay. I will send it to you the day of.
Yeah, every single problem you look at on the test, you're doing it from scratch. And
you're
so
right.
It's not what the strategies you want to learn are. What strategies do you use when you're looking at it for the very first time? Not, after I've looked at it for 20 minutes and I figured out the answer and now I can explain it to you much easier, but you don't get to see my pattern of solving a problem that's difficult.
Okay, I will do that then.
So you can do it either way. I'm just pointing out the differences.
Sure. Okay, great. Thank you.
Carolyn. Talk to you next time. Bye-bye.
Okay, bye.